Hi, my name is Talia. Welcome if you're new, welcome back if you're not. I'm an incoming third year student at UC San Diego and I study chemistry, minoring in science education. This YouTube channel is an extra resource for anyone who may be needing some extra help in their chemistry classes. In this video, I'm going to be wrapping up nuclear chemistry and talking about some factors that determine stability. Specifically, I'm going to be talking about binding energy, the band of stability, and magic numbers, and also going over what stability is. So if you need help with that, I hope you will keep on watching. And without further ado, let's get started. All right, let's get going. So before I get into the factors affecting stability, I'm going to talk about what stability is. So this whole unit, I've been talking about radioactive isotopes and their decay and nuclear radiation and what's emitted from isotopes when they decay, but what determines whether an isotope will decay or not? And that is its stability. So isotope stability correlates to the proton to neutron ratio. But it will become a little bit more advanced than that, as I will talk about in the following slides. But it's similar to how ion charge correlates to the proton to electron ratio. Stable nuclei are non-radioactive and unstable nuclei are radioactive, which we've seen. A stable isotope like carbon-12 is not going to spontaneously decay versus something more unstable like carbon-14 is more likely to decay. And as I talked about in the previous video, the rate at which any nuclei decay to half of their amount is called the half-life, and unstable nuclei have a smaller half-life than stable nuclei. Okay, so the three factors I'm going to be talking about today are binding energy, the band of stability, and magic numbers. So first, binding energy. What is it? So this should say that binding energy is the energy required to pull apart the subatomic particles in a nucleus. If an element has a higher binding energy, it means the nucleus is more stable. Binding energy is measured in units of mega electron volts, and specifically it's in mega electron volts per nucleon. And in the equation that we can use to calculate the binding energy is E equals mc squared, which you may have heard of before. E represents the energy in joules, which you can convert to mega electron volts. M is the mass in kilograms, and C is the speed of light. So this is a graph that shows binding energy. The highest binding energy is iron 56. So anything before that, the increase of protons increases the binding energy. And then once you go past iron 56, you have so many protons and the binding energy actually decreases. So in order to get more stable, atoms that have lower atomic numbers will undergo a process called fusion. Well, they'll come together to make an element with a higher atomic number or more protons and therefore more stable. And an atom with a higher atomic number will do the opposite. It'll split in a process called fission in order to get on the other side of the iron 56 curve and become stable. Okay, next we have the band of stability. And like I mentioned with stability in general, the band of stability relates to the proton-neutron ratio because the neutrons in a nucleus decrease the proton repulsion. So the band of stability is this little black part in the middle of the graph, and anything outside of it is unstable. Pretty straightforward. If you have more than 83 protons, you're also not going to be stable, or the element will not be stable. Okay, finally, we're going to talk about magic numbers. And this is a very short definition. There's pretty much nothing on this slide. But these are just isotopes with nuclei that have a total sum of protons and neutrons that equal 2, 8, 20, 28, 50, 82, and 126. And this just makes them unusually unstable. All right, so that was the end of this video on stability. I didn't get to go too far in depth because I was just covering probably what you would cover in a high school chemistry class. But if you have any questions or comments, feel free to leave them in the comment section below, and I'll do my best to answer them. Next time, I'm going to be jumping into equilibrium, which is a super exciting unit, and I'm going to also shift into some topics that you may be learning if you take AP Chem. So if you want to learn more about that or need some help, join me next week. I look forward to hopefully seeing you. I hope you enjoyed this video and good luck with learning chemistry.